Hi, Algebra 1 students. Here we are in Chapter 2, and we're looking at Section 2.2. We're going to be adding and subtracting rational numbers. So today in our vocabulary, we're going to talk about opposites in terms of numbers, and we're going to talk about additive inverses. And thankfully for us, they're both the same. So every number has an opposite. The opposite of 5 is negative 5. The opposite of, let's say, 7 is negative 7. Of course, the opposite of negative 1/3 is a positive 1/3. And the beauty of these guys is that when you add them together, 5 plus a negative 5, or 7 plus a negative 7, and negative 1/3 plus 1/3, you get 0 in each case. So opposites, numbers that are opposite of one another, are also additive inverses. Now for our first example, if you need to use a number line, cool, but from talking to you guys, I think you may not need a number line. So using a number line to add is all well and good. You would start off with, we're here at 0, you'd start off with negative 3, let's say it's there, and then you would count backward 4 from negative 3, and you would end up at negative 7. I know I did not demonstrate how to do that at all. In fact, I think I am interested in you having some rules down around adding and subtracting negative and positive numbers if you're not familiar with it. So what I'll do is I'll put those rules up. And here we are when adding integers, when we've got the same sign, and really this refers to any positive numbers or negative numbers, not just integers. But when adding numbers that are both positive, you're going to add them as you normally would. They're going to remain positive. If you add two numbers that are negative, you're going to add those as you normally would, and the answer would be negative at the end. And you can think about it as my folks gave me $4, then they gave me $5, altogether I had 9, or I owe my cousin $4, now I borrowed more and I owe him $5, altogether I have a debt of $9. So that's pretty basic. Now when it gets a little bit confusing is when we're talking about different signs. If you're adding two different signs, ultimately you're subtracting because you're going to be adding in one direction but taking away in another. Right? We can think about it in terms of temperature sometimes. If I start off at negative 4 degrees and then I add 5 degrees, our overall temperature would be a positive 1, and so, or would be 1 degree. And so that works both ways where you're adding a positive to a negative or negative to a positive. What you'll do is you'll subtract the two numbers and keep the sign of the bigger, I say the bigger looking number, right? So negative 5 is bigger here, so your answer is going to be negative. Positive 5 is bigger here, so your answer is positive, right? And that just means like 5 is bigger than 4. Anyway, I'm going to post these rules and make sure that they're available in your, they're available for you to take a look at, and they'll be on Google Drive. So as our rules just told us, I'm adding a negative 3 and a negative 4, right? Sometimes, by the way, you'll see negative as a higher, like written up here. Some textbooks don't do that, so that's why you see the parentheses. There's nothing really going on in the parentheses. It's just to say, hey, this negative hangs out with that 4. So anyway, negative 3 plus a negative 4 is going to be a negative 7. Just add, keep the sign the same. Over here, we've got two numbers, right? A positive and a negative. Which one's the bigger looking number? This 3.5 is bigger than 2.5. Therefore, I'm going to take the sign of the 3.5. My answer is going to be negative. I'm going to subtract 3.5 minus 2.5 is 1. All right, so here we are in example 2, and it's really the same idea. We're adding rational numbers. Remember, rational numbers are any numbers that can be written as a fraction. So negative 11 plus a negative 7 is going to give me negative 18, right? Just add the two numbers and make sure the sign is negative because both of them are negative. And here we have a situation where, one, we're dealing with fractions, and two, we're dealing with the problem where we're adding two numbers with a different sign. So the fact of the matter is, which fraction is larger? Is it this guy or this guy? Because that's going to tell me, that's going to inform me as to what sign the answer would be. So the best way to compare fractions is to make sure we have the same denominator. So we'll start off by getting that. Well, what number does both 8 and 16 go into? Yeah, 16. And our new numerator here will remain the same. and we get 7 up here, and down here we're going to get, and we get a 6 here. If this is not making sense in terms of fractions, because I know a lot of people have issues around fractions, let's talk. We can do like a one-on-one, hey, boot camp fractions, let's get back into it. But anyway, for our intents and purposes, we're just going to act like we kind of remember a lot of these rules. So we've got our common denominator. Notice to get this guy, I'm still explaining, right? Notice to get this guy, we had to multiply top and bottom by 2 in order to get this change of fraction. The change in the look of fraction is still equivalent. Anyway, 7 plus a negative 6 is going to be a positive 1 over 16. So I've got 1/16 as my final answer here. I hope that makes sense. So remember, when we add fractions, we don't add the denominators, just the numerator. The denominator comes along for the ride. And when we're adding two numbers with different signs, the answer is going to take the sign of the number that has the highest value, the highest absolute value. All right, let's look at another example. In fact, instead of looking at another example, I just want to take a glance at these, and I just want you to do them with me, if that's okay. So this is guided practice, and this is in your textbook, and sometimes I will talk about such things. The other example just didn't seem really useful or beneficial. So let's take a look. In each of these problems, we're going to be doing adding, so let's just talk about what we do. I don't necessarily have to have the answer. So if I'm adding a negative 15 and a negative 12, my answer is going to be negative, and I'm just going to add. If I'm adding a negative 24 and a negative 45, answer is negative, just add. If I'm adding a 38.7 and a negative 52.9, the answer will be negative because the number that is the greatest, now I know negative 52 isn't bigger than 38.7, but it is the greatest absolute value. It's like the number that's the furthest from 0 will have the most power over the problem. So this negative 52.6 tells me that my answer is going to be negative, but instead of adding the numbers like I do in these situations, I'm going to subtract. Got it? All right, hopefully this is making sense. Here, just add, the number is going to be negative. The answer is going to be negative because they're both negative. Here, we're going to subtract. Okay, over here we've got our fractions, and so 4/7 and a negative 1/2, which one is bigger? We would make a common denominator. In this case, it would be 14, since that's a number that both 2 and 7 can go into. Our new numerator here would be 8, because technically I'm multiplying top and bottom by 2. Our new numerator over here would be a negative 7, because I'm multiplying top and bottom by 7. And so what I realize here is that my answer is going to be what? You got it, positive, good, thank you for answering. And then my answer is going to depend on me subtracting these two because they've got different signs. Again, subtracting the two, they've got different signs. My answer in this problem is going to be positive. By the way, you never have to put a plus sign next to a number to indicate its positivity. You can just leave it. Here we're finding the difference, and this is something we didn't talk about in the video, but you'll see, earlier, but you'll see it in the other examples, and not the other examples, but in the handout that I'm going to put in the PDF on Google Drive. So if I'm adding 18 plus 23, it is equivalent to adding 18 plus a negative 23. I think I said that wrong. If I'm subtracting 18 minus 23, it's the same as adding 18 plus negative 23, and then your addition rules apply. So some school of thought tells you to never do a subtraction problem, always change your subtraction to addition. Let me use a different pen here. And so one thing that a student will do is something called keep, change. And this works anytime you're subtracting two numbers. So if I have 2 minus a negative 3 and I want to change it to an addition problem, it will be keep the 2, change the minus to a plus, and change the sign on this next number to a positive 3. So 2 minus a minus 3 is actually 5. And that will be the same here. We would keep this, change this, change this. Keep this, change this, change this. Keep this, change this, and change this. You see where we're going? Keep this, change this, change this. Keep this, change this, change this. And then you're going to follow the rules that we did for addition. I hope this was helpful, and I look forward to talking to you, seeing you, whatever, hanging out in the next video. Take care.